For the purpose of our mathematical calculation, we're going to use a 2-inch effective overlap, even though we would argue that such overlap really doesn't exist at all. If the average rubberized area is 50 feet wide, and we use two 21-inch spray heads married together for a total of 42-inch blasting pattern, you notice that the effective blasting area is 40 inches in width. Now note that the water blasting technology's linear way of thinking, the blasting heads never travel in a lateral direction, thus completely eliminating any lateral overlaps. Assuming a 50-foot wide rubberized area and 2,000 feet long rubberized area, and assuming a 40-inch wide blasting pattern, 15 linear passes are necessary down the runway to clean the rubberized area with the linear technology. If we take a 2-inch overlap, divide it by 12 to come up with feet so that we can calculate square feet, you'll see that 0.17 multiplied times the 2,000 feet distance results in 333 square feet wasted due to overlap per pass. We then take that 333 square feet, multiply it times the 15 passes necessary, and you quickly calculate that there is 5,000 square feet wasted in overlaps on an area of runway to be cleaned. Compare that 5,000 square feet with the 35,306 square feet represented by the laterally movement machine. Now, there are two things to consider when talking about these overlaps. One of them is efficiency. Another of them is impact to the surface. True enough that water jets can clean a surface and do so and create very little to no impact to the surface. However, if you leave that machine sit in any area for any length of time, it will most certainly damage the runway and remove aggregate and bitumen from that surface. So this much can't be argued with. The fewer times you pass over that surface, the better off you are. Just as important is the efficiency of the machine. How fast does the machine clean the surface? If you're passing over areas 2 and 3 times, it doesn't make any sense. So the linear method creates less opportunity for any damage to occur, and secondly, it increases the speed at which you're able to clean any given rubberized area. Everybody understands on some level that horsepower is capacity. The higher horsepower you have in your car, the faster you can go, and the less time it takes you to go there. The more horsepower you have in your lawnmower, the wider path you can cut, or the taller grass you can cut, or the less time it's going to take you to mow that grass. Water blasters are no different. The most popular model of the Stripe Hog runway cleaning system utilizes a 12-gallon or 45 liters per minute. This is double the capacity of our competitors, and there's one clear reason why. Remove more rubber in less time. In fact, you'll find that our advertised removal rates are nearly 3 times that of our competitors. The reason is clear. By having more horsepower on board, we're able to push more water out the nozzles and clean more area in the same amount of time. You also notice that instead of one 10-inch wide head, we're able to have 2 21-inch wide heads and power those heads effectively because we have so much water moving through the nozzles per minute. This is a very important fact. Lateral track machines advertise 800 square meters per hour. We have proven the world over our ability to remove 1,800 square meters per hour. There are 2 reasons for that. Increased horsepower capacity resulting in the ability to clean more area faster. Secondly, the elimination of overlaps that we've discussed previously means that our cleaning operation is that much more efficient. Thirdly, let's talk about water consumption. We do use more water per minute, but do we use more water overall? The answer is a resounding no. Because our unit is more efficient than laterally movement machines, we actually use less water. Do the math for yourself. Use their advertised removal rates of 800 square meters per hour and 6 gallons a minute. This will result in 0.45 gallons used per square meters cleaned. Consider that with the linear technology. Use our advertised removal rate of 1,800 square meters per hour and 12 gallon minute consumption. And you'll quickly calculate that we use only 0.40 gallons per square meter cleaned. But wait, there's more. Water Blasting Technologies is the first company in the world to reuse water in a 40,000 psi or 2,800 bar condition and recycle it right back through the blasting head. For well over a year now, Water Blasting Technologies has been producing water recycling units and sending them around the world. You'll see here a unique patented process that allows us to take in fresh water, run it through a series of filters, and then through some very clever processes and inventions, we recycle that water straight back into the clean water tank and lose only about 200 gallons per day to evaporation and efficiency loss. We've run machines for over 2 weeks without ever changing the water in that machine. This is very important when you're talking about very short work windows on busy runways. How much more importance can be given to achieving that extra couple of hours traditionally lost to going to the fire hydrant and filling with new water? It's huge. Furthermore, consider the environment. Yes, we do have a great filtering mechanism that filters out and dries our rubber debris prior to dumping. But consider now, not only is that dumping not necessary, we're not using more water to begin with. Water can be a very precious commodity in parts of the world, such as Australia and other places where water is in short supply. So make sure you give adequate consideration to this important point. Fourthly, let's talk about visibility. When you're blasting a surface, conditions are always changing. Rubber is far heavier on the inside of the runway, far less heavy on the outside. You want to always be able to adjust to the ever-changing conditions present. Visibility before the blast head is important to establish your path that you're running on. Visibility after the blasting head is very important because you need to see the area that you've cleaned in order to establish whether you're moving too fast or whether you're moving too slow. Take a look here at how impossible it is to see what you've blasted on the laterally tracking machines. And then conversely, take a look at how easy it is to see the surface immediately in front of and immediately behind our linear way of thinking.